September 29, 2025. Firefly Alpha explodes during a static fire test at their Briggs, Texas facility. The entire first stage is gone. The test stand severely damaged. This marks their second catastrophic failure in 6 months, following April's Flight 6 disaster. Stock plummeted 11% in after-hours trading. Lockheed Martin's payload survived, but they're now seeking alternative launch providers. With 2 consecutive failures, industry analysts are questioning, can Firefly recover, or will Alpha be permanently grounded? Let's dive right in. Let's start with the facts. Early Monday afternoon at Firefly's Briggs, Texas facility, the engineering team was executing a standard pre-launch procedure, a static fire test of the Alpha Flight 7 booster. This wasn't experimental. Static fires are industry standard. SpaceX does them. Rocket Lab does them. It's the final checkpoint before stacking the second stage and integrating a customer's payload. The setup was textbook. 4 Reaver 1 engines burning, RP-1 kerosene, and liquid oxygen, bolted to the test stand, generating thrust while the rocket stays grounded. The test verifies engine performance, fuel system integrity, and structural stability. Everything looked normal during prep. Then in a fraction of a second, catastrophe struck. The explosion was instantaneous. A massive fireball consumed the booster, sending a tower of black smoke into the Texas sky. Seconds later, a second blast followed, so powerful that security cameras at a nearby car dealership shook from the shockwave. Witnesses reported feeling the impact miles away. Fortunately, strict safety protocols meant no injuries, but the test stand took severe damage, and the entire first stage was destroyed. Firefly issued a statement within hours, confirming an event that resulted in a loss of the stage, but providing no root cause. That investigation is still ongoing. What makes this failure particularly troubling is the timing. This didn't happen during the high-stress environment of launch or flight. It happened on the ground, during a test specifically designed to catch problems before they become disasters. The market reaction was swift and brutal. Within hours, Firefly's stock plummeted more than 11% in after-hours trading on September 29th. But the financial damage extends far beyond that single-day loss. The destroyed booster represents tens of millions in lost hardware. The test stand will require extensive repairs, potentially months of work depending on the structural assessment. Alpha Flight 7, originally scheduled for October 2025, has been pushed back to 2026 at the earliest. In the commercial launch industry, every month of delay translates to lost revenue and eroding customer confidence. There's a silver lining worth noting. Because the explosion occurred before stage stacking, Lockheed Martin's payload survived intact. That's critical. Under their multi-mission agreement with Firefly, up to 25 launches through 2029, this was the 3rd planned mission. The satellite is safe, but the launch timeline is shattered. Industry sources indicate Lockheed Martin is already exploring alternative launch providers, with SpaceX's Falcon 9 at the top of the list. When your anchor customer starts seeking backup options, that's not just a business setback. It signals a fundamental crisis in reliability. Here's where we need to address the uncomfortable reality. This is Firefly's second catastrophic failure in 2025. The pattern demands scrutiny. In April, Alpha Flight 6, dubbed Message in a Bottle, launched from Vandenberg Space Force Base carrying Lockheed Martin's LM-400 satellite. During flight, the second stage Lightning 1 engine shut down prematurely. Mission failure. Satellite lost. Firefly's investigation revealed critical findings. The first stage booster flew at a higher angle of attack than previous missions, exposing one side to recirculating hot exhaust from the Reaver 1 engines. This created flow separation and thermal damage to the booster structure. When the first stage separated, that structural damage generated a shock wave that destroyed the upper stage engine, killing the mission. Now consider the progression. Flight 6 failed due to first stage structural and thermal issues during flight. Flight 7 exploded during a ground test, also involving the first stage and the same Reaver 1 engines. 2 failures in 6 months, both connected to first stage systems. This isn't coincidence. It suggests potential systemic issues with either the Reaver engine design, manufacturing quality control, or testing procedures. Firefly's recent struggles have made them a target in the notoriously competitive space industry. At the Berkeley Space Symposium 2025 earlier this month, Astra CEO Chris Kemp, a former partner turned rival, launched a public attack on Firefly's engineering capabilities. "There is a company called Firefly. They went public," Kemp stated, barely concealing his disdain. "We bought the engine from them, and it was garbage. We literally could not get the same engine twice from them, and none of them matched the CAD. If you're in engineering, you know that just doesn't work." Kemp's comments ignited controversy across the space community. Firefly's leadership chose not to respond publicly, a wise strategic decision. But his criticism, however harsh, raises legitimate questions. When you experience 2 consecutive first-stage failures, when engines can't pass static fire tests, when boosters can't handle aerodynamic stress, these failures suggest possible inconsistencies in manufacturing or quality assurance. Kemp didn't stop at Firefly. He's also made inflammatory remarks about SpaceX, claiming Astra offers better working conditions than Starbase in South Texas, joking about border safety concerns. His confrontational approach has alienated many in the industry, but his core criticism of Firefly's engine reliability touches on real concerns that the September 29th explosion has only amplified. Amid the Alpha program's turbulence, Firefly achieved something extraordinary that deserves recognition. They landed on the moon. On March 2, 2025, Firefly's Blue Ghost lunar lander executed a soft landing in the Mare Crisium region, making them the first commercial company worldwide to achieve this feat. The mission, officially named Ghost Riders in the Sky, exceeded all expectations. The results speak volumes. 10 NASA science instruments delivered successfully, 100% mission objective completion, over 119 gigabytes of scientific data collected, and more than 14 days of operational time on the lunar surface, the longest duration ever for a commercial lunar mission. Blue Ghost wasn't just successful, it was a masterclass in precision engineering and mission execution. This achievement positioned Firefly as a serious contender in NASA's Artemis program and proved the company possesses world-class engineering talent capable of executing complex deep space missions. Blue Ghost generated significant positive press and strengthened relationships with NASA. However, we need to be realistic about what this means for Alpha's future. Blue Ghost and Alpha are separate programs with different engineering teams, different customers, and different revenue streams. You can dominate lunar exploration while simultaneously struggling in the commercial launch market. Blue Ghost bought Firefly credibility and breathing room, but it cannot compensate for repeated Alpha failures. While Alpha stumbles, Firefly is making a massive strategic bet on Eclipse, a medium-lift vehicle developed in partnership with Northrop Grumman. This partnership could either save the company or compound its problems. Eclipse, officially named in May 2025, represents a quantum leap in capability. The 2-stage rocket can deliver over 16 tons to low Earth orbit or 3.2 tons to geostationary transfer orbit. That's roughly 15 times Alpha's payload capacity. With a partially reusable design, Eclipse is positioned to compete directly in the lucrative medium-lift market currently dominated by SpaceX's Falcon 9. The development timeline is aggressive, but showing tangible progress. By June 2025, the first engine bay completed structural load testing, simulating maximum forces from launch through max Q, the point of maximum aerodynamic pressure. The 7 Miranda engines powering Eclipse, upgraded versions of Alpha's Reaver engines, have completed over 90 hot fire tests at the Briggs facility, including full power burns and complete mission cycle simulations. Northrop Grumman's $50 million investment in May 2025 pushed Firefly's Series D funding over $225 million, accelerating production timelines. The maiden flight is targeted for late 2026 from Launch Pad 0A at the Mid-Atlantic Regional Spaceport on Wallops Island, Virginia, the same facility where Northrop's Antares rockets launch. Eclipse serves a strategic national purpose beyond Firefly's commercial interests. The Antares 330 series will use Eclipse's first stage, replacing Russian components that became unavailable following the Ukraine conflict. This positions Firefly as critical infrastructure in America's space supply chain. But here's the critical question that keeps industry analysts up at night. If Firefly cannot consistently operate Alpha's 4 Reaver 1 engines reliably, what does that mean for Eclipse's 7 Miranda engines? The Miranda is an evolution of the Reaver design. If fundamental issues exist in the base technology, whether in combustion dynamics, manufacturing processes, or quality control, those problems could propagate to Eclipse. Firefly operates with one significant advantage that shouldn't be underestimated: political support. The current administration has made American space dominance a priority, translating to favorable conditions for domestic launch providers. On September 15, 2025, U.S. federal judge Carl Nichols dismissed an environmental lawsuit challenging SpaceX's Starship operations at Starbase. This decision followed President Trump's August 13, 2025 executive order relaxing commercial launch regulations through 2030. The message from Washington is clear: remove barriers for American space companies. Firefly benefits from this environment through the Northrop Grumman partnership and Eclipse's role in national security missions. The company has positioned itself as essential to America's space infrastructure, particularly for defense applications. This political backing could manifest as additional government contracts, regulatory flexibility, and potential financial support if circumstances become dire. However, political goodwill has limits. Government contracts require successful launches. NASA and the Department of Defense demand reliability. No amount of political support compensates for rockets that explode during ground tests or fail to deliver satellites to orbit. The space industry operates on razor-thin margins for error, especially in the commercial launch market. Firefly now faces a harsh reality. How many failures can they survive before customers abandon ship permanently? Strike 1. Alpha Flight 6 in April. Complete mission failure. Lost satellite. Root cause traced to first stage design issues. Strike 2. September 29th. Test stand explosion. Total loss of booster. Severe infrastructure damage. Launch schedule decimated. Strike 3 would be catastrophic. Whether it's another Alpha failure, problems during Eclipse development, or any additional incident that undermines confidence, the consequences could prove terminal for the Alpha program and potentially threaten the entire company. The commercial space market shows no mercy. Rocket Lab's Electron boasts a proven track record with over 40 successful launches. SpaceX's Falcon 9 is the industry benchmark for reliability with hundreds of consecutive successes. Emerging competitors like Relativity Space and ABL Space Systems are hungry for market share. If Firefly cannot demonstrate consistent reliability quickly, their customers will find alternatives. The investigation into the September 29th explosion continues. Firefly has committed to transparency once the analysis concludes. That report will be pivotal. A simple, fixable cause, a manufacturing defect, procedural error, or isolated component failure gives Firefly a clear path to recovery and restoration of confidence. But if the investigation reveals deeper systemic problems with Reaver engine design, quality control processes, or fundamental engineering approaches, Firefly faces an existential crisis. They would need to make difficult decisions about whether to continue Alpha development, how to protect Eclipse from similar issues, and how to rebuild shattered customer trust. Here's the bottom line. Firefly stands at a crossroads. 2 first-stage failures in 6 months reveal a critical pattern with the Reaver engines. The investigation report will either identify a fixable problem or expose deeper systemic issues that could derail both Alpha and Eclipse. What this means for the space industry is significant. America needs multiple reliable launch providers, not just SpaceX. Firefly proved their engineering excellence with Blue Ghost's lunar landing. The Northrop Grumman partnership shows the defense sector still believes in them. But belief doesn't launch satellites. Reliable rockets do. Eclipse's late 2026 maiden flight will be the defining moment. 7 Miranda engines must prove Firefly learned from Alpha's failures. Success could secure their future. Another failure could end the program. So here's my question for you. Can Firefly turn this around, or is Alpha finished? Drop your prediction in the comments below. If this analysis delivered value, hit that like button. Subscribe to Space Hub for expert breakdowns of space industry developments. And turn on notifications. Firefly's investigation report drops soon, and we'll break it down the moment it's released. This is Space Hub. We don't just report space news. We help you understand what it actually means. The countdown to Eclipse has begun. China just announced reusable rockets to challenge SpaceX. Bold move. But here's what the data reveals. SpaceX has landed over 500 boosters, with some reflying 20+ times. China? Still testing prototypes with zero operational reusable rockets. The numbers are brutal. SpaceX carries 85% of the world's orbital payload. China launches dozens of rockets yearly, all expendable. And by the time China fields its first reusable rocket in 2026, Starship will have already changed the game completely. This is about economics. SpaceX, $2,700 per kilogram. China, locked into expensive, single-use hardware. The gap isn't closing. It's widening with every Falcon 9 landing. Let's dive right in. To understand why China's struggling, we need to start with what made SpaceX's breakthrough so devastating. Before 2015, every rocket launch meant discarding tens of millions of dollars of hardware. Launch once, throw it away? The space shuttle tried reusability, but was so complex and expensive that it actually cost more than expendable rockets. Falcon 9 changed the equation. When that first booster landed successfully in December 2015, it proved something critical. You could bring a rocket back, refurbish it, and fly it again, profitably. That single achievement transformed space launch from an expenditure into an investment. This is the revolution China missed in real time. While SpaceX was perfecting this capability through years of testing, crashes, and incremental improvements, China's space sector was focused on expanding its expendable rocket fleet. By the time Chinese officials recognized reusability as essential, SpaceX had already completed over 100 successful landings. That timing matters more than most people realize, because reusability isn't just a feature you can add to a rocket. It requires fundamental design choices from day one. Chinese engineers have access to videos of every Falcon 9 landing. They can study technical papers, analyze trajectories, and examine the basic principles. So why haven't they replicated it? The answer lies in understanding what reusability actually demands.